Alright class, so now we'll take a look at example 6 from lesson 2.2. You're given these two functions f of x and g of x, and then we want to be able to show that as x increases to positive infinity or decreases to negative infinity, that they're in behaviors, okay, that their limits approach the same thing. Okay, so let's take a look at this. Okay, so how would I demonstrate that? Let's take a look at this graphically first. Okay, if you turn to decimals or with your graphing calculator, let's take a look at this. Okay, so back to home screen. As you can see, for a small set of x values, their y values, their corresponding y values are quite different. But as you zoom out, and as you see that if you increase your x values or decrease your x values, they're in behaviors, the graphs are virtually identical. They're matching. Okay, that tells you that you're approaching the same value as your same y value as your x value is approaching positive infinity, and as your x value is approaching negative infinity. And to show this algebraically, one way to show that is to simply show that the limit of f of x over the limit of g of x, or vice versa, as x approaches positive infinity in this case, would simply be that ratio will be 1. Okay, that's what we want to show. So let's go ahead and do that. Okay, so we are going to show the fact that the limit of the 3x to the fourth power minus 2x to the third power plus 3x squared minus 5x plus 6 all over 3x to the fourth. Okay, we want to show that that's equal to 1. Okay, I'm going to put a question mark there. Okay, and the way we approach this kind of problems, okay, whenever you're finding the limit of limits as x goes to infinity of a polynomial function divided by another polynomial function, the technique that we used is to divide top and bottom by the term with the highest degree, the x term with the highest degree of the denominator. So you divide both the top and bottom by x to the fourth power. In turn, your expression changes to, what do we have here? 3 minus 2 over x plus 3 over x squared plus or minus 5 over x to the fourth power plus 6 over, oh gosh, 6 over x to the fourth power. That's okay, I made a mistake on the fourth term. That should be x to the third power. And on the bottom, you're only gonna be left with 3. But because we're dealing with the limits of the numerator divided by the limit of the denominator using the limit property, and also the fact that you have the differences and sums on the top, you could use a limit property again to find individual limits of each. And the limit of the second term would just be 0. 2 over x as x approaches infinity would be 0. This will be 0, that will be 0, that will be 0. So in the end, you end up with 3 over 3, which just becomes 1 right there.